itself, I think it's still an iterative algorithms because it's an adaptive filters. Okay, I'm not sure if my interpretation is correct or not. Okay, but at least adaptive filter, I think itself is still the iterative algorithms. So it seems to me that the unfolding, because unfolding means you kind of first the original iterative algorithm is you perform one iteration at a time. Okay, now you unfold it so you can do multiple iteration at the same time. So that gives you a more space for the possibility of optimization.
Okay, yeah, but
so
maybe two, yeah.
Yeah.
The point is that, yeah, if I understand correctly, your question will be, okay, we have unfolded this original iterative algorithm as this figure, but I still iterate in the training process. That could be right. And yeah, it is actually true. But the point is that for this iteration, we have already seen that this is actually a framework of deep learning. And in the deep learning, they have succeeded in the design of the optimizer or something. So we rely largely on this kind of success for this upgrade. But in this upgrade, it depends on actually domain knowledge of the system. So we want to optimize these guys here by using the success of deep learning technique. That is the basic main idea of this approach. So that's why, actually, yeah, of course, the performance largely depends on, for example, the choice of hyperparameter over or something. So that might be possible to further improve. Maybe we can also utilize the idea of deep unfolding for this part as well. Might be, I'm not sure about that. But yeah, so far, yeah, maybe my question answer is something like this. So we rely or believe the success of this deep learning technique.
Yeah, I'm not trying to challenge you.
Oh, yeah,
I think it's very interesting.
Yeah, thank you.
But I think I have one more question. Is that regarding the last two examples you gave, okay, is SCCP and OPTN for the signal distortion compensation. Because I mean the conventional approach is that okay, you perform the distortion corrections one at a time. You will not try to do them simultaneously. For example, first you may achieve the coarse timing simulation first, or then you perform the carrier frequency offset, okay, and then IQ imbalances. So you do it one at a time, okay. So I mean, the conventional approach you will not try to do them all together because without the initial simulation you cannot do channel equalization, okay, something like that, okay. So in that regard, okay, it is really beneficial that you try to solve everything all together, okay, because in your kind of unfolding approach, okay, I think your goal is that okay, we can actually do the adaptive or the adjust the parameter for each filters, okay, in different sections all together simultaneously. We don't have to do it one at a time. Okay, but conventional wisdom, it seems that you try to solve the the basic problem first, and then you try to solve the more difficult one. Okay, so yeah, so that's I'm a little bit confused about this one, and also for example, such IQI imbalance problem or the CFO compensation problems. Normally, we just collect a set of data and try to calculate for example, the phase difference. Then we have a deterministic method to calculate the imbalance parameters or the frequency offset. Then we compensated it deterministically. But it seems you use the adaptive approach, okay, to that kind of gradually. I mean, what's the beneficial of using the adaptive approach in signal distortion correction when compared to the conventional kind of you have mathematical models and you collect the data, you calculate the kind of the phase difference, and then to to do the conversation directly.
So I think the main merit advantage of our approach is that with this classical approach, basically you need some kind of parameters of distortion, right? For example, if you try to compensate IQI in a deterministic manner, this IQI parameter should be estimated at least. So we believe that this might be difficult in some situations. Of course, this might be possible, for example, typical wireless communication system. But for example, if we consider, say, the application of IoT or something, in that case, we have many very cheap terminals.
Okay.
In that case, it may be difficult to accurately estimate each IQI parameters. Maybe in such scenario, our approach might be beneficial. So that has to be one possible approach. But actually, you mentioned about synchronization problem. Right? Actually, we think this, we actually really want to incorporate the synchronization as well in the multi-layer filter. But somehow we have not succeeded in it. But we believe this synchronization issue will be actually very, very important problem in the actual communication system. So yeah, I try to include this kind of issue. And actually, our final goal is not only the receiver size. Maybe we can consider this kind of multi-layer filter, including the transmitter size as well. So maybe we can also simultaneously optimize the transmitter parameter, maybe a pre-coding or maybe even the modulation parameter or something. So that might be one possible final goal of this approach. Yeah.
Okay, any questions? Okay, no. Let's thanks Professor Hayashi again. Okay, thanks.
Thank you very much.
Oh，就结束了。